So this is the first of a series of videos on algebra. This is to start off with revision for what you did in grade 8. It will lead us on towards the last topic in our term, that is solving algebraic equations, including practical applications of those. So our goal here today is just understanding how to classify the different components or elements of expressions and equations and algebra terminology. This is a diagram from your textbook. What it shows you is the different parts and how they all fit together. So to start off with, we have what we call a term. So a term is a collection of digits, numbers, and algebraic components, which we call pronumerals. When they're next to each other like that, it means multiply. The coefficient is the digit or number in front of a pronumeral, which means 5 lots of or 5 groups of. Basically means multiply in this case. And the pronumeral is the algebraic component, which is in this case a letter. Now in these ones we have x's and y's as our pronumerals. We also have another term here where there are no pronumerals, no algebraic component. They're called constant terms because they don't change. They have no variable component. Now it's important to understand that this negative here, we'll talk about it a bit later, could also be written as plus -3. Now when you have a collection of terms together, like these three here, we call them an expression. Now we actually have two expressions on both sides of those equal signs. And when you have an equality sign, which includes equals, we have an equation, that is two things that equal each other. Here's the definitions of those items there. We have terms, which are groups of letters or numbers. We have coefficients, which is the number part of that term. If there's no number present, it means the number 1. That's important, don't forget that. And it also means when you have a number next to a pronumeral or a letter, it means multiply. Now the pronumeral is the letter part of the term, the algebraic component. Not all parts contain pronumerals, and it represents a quantity. That is, that number, that letter could represent any number. We also have constant terms, which is the ones that do not have pronumeral components. Now, expression is a series of those terms. There's no equal sign. And finally, we have an equation, which generally has a left-hand side, a right-hand side, and in between them an equality sign, or an inequality if we want it less than or greater than. So let's look at some examples. So for this question here, we're just going to answer some questions. You may want to have a go at them yourself by pausing the video. So this one has a number of terms and 3 pronumerals, which are x, y, and z, scattered throughout. So let's look at the first one. State the number of terms. 1, 2, 3, 4, 5, 6. They're the components that are separated by plus or addition and subtraction signs. The second one is the coefficient of the second term. So that's this one here. First term, second term. The number in front is the 3. Means 3 times the xy, and the minus sign is associated with the 3 because that could also be rewritten as plus -3xy. So the coefficient is actually -3. The constant term is the one without any letters, any pronumerals. So in that case, that's this 2 here. And D, state the term with the smallest coefficient. So the smallest doesn't mean the smallest magnitude, it means smallest on our number line. So that means negative numbers. So the only one with the negative one here is -3. So the term we're looking for is -3xy. The second smallest term is this one here. There's no other negative, so then we start looking at fractions. So this y squared divided by 7 could also be rewritten as, let me just write it up for you, 1/7 y squared. So that's important to understand. That's what that looks like. Okay, let's look at the next page. A couple more questions. Same expression. Coefficient of the last term, we just talked about that. That's actually 1/7 times y squared. So fractions are interchangeable with division. Coefficient of the x term. So the x term is the one with just an x in it. It's this one here. Coefficient is a number in front, which is 6. Alright, so now we have some algebraic substitution, which is the second concept we're looking at today. Now, you're already familiar with a large variety of formulae. You've been using them since grade 5, possibly. The most one of the first ones you saw was area equals length times width, that is, area of a rectangle. We see formulas in all sorts of different places, not just maths and science, but PE, history, everywhere. So when you're using a formula, you substitute the letters by replacing them with numbers. Now, like I said, we've been doing that for a while. Now, it's not necessary in this particular case to write the multiply sign. It's assumed that if there's two pronumerals next to each other, then it means multiply. So let's look at some examples of substitution. So we've got x equals 3, y equals negative 2. I'm just going to evaluate some of these expressions. So 3x plus 2y. What we're going to do is substitute the 3 in for the x and substitute the negative 2 in for the y. Now my advice is whenever you're substituting, substitute them in with brackets. This avoids confusion. For instance, if we look at the second part here, the 2y equals 2, and some people like just to do this, 2, negative 2. And there's some confusion there that might look like 2 take 2, which is 0. We know that's not true. This actually means times or multiply. So what we should be doing is 2 times negative 2, which equals negative 4. Now by using brackets, most calculators are able to correct or avoid any issues we may have with negatives, and that's my recommendation. So whenever you substitute, place them in brackets. So that's 3 times 3 is 9, plus 2 times negative 2 is negative 4. So the answer there should be 5. There we go. Let's look at another example using the same variables. This time we've got a more complex expression where we're multiplying 5 by x by y. So the same first step, we substitute x and y. So wherever we see an x, we replace it with a 3, here and here. And then we replace the y with negative 2. As I said before, place them in brackets. So that's 5 times 3 times negative 2 is negative 30. Negative minus 3 times 3 is minus 9 plus 1. So remember that minus sign there, subtraction sign, goes with the 3. So that's like thinking about that as, so minus 3x could also be rewritten as plus negative 3x. And once again, excuse my poor mouse skills. So we work that out. You get negative 30, take 9 plus 1 is negative 38. So that's substitution. Here's another one. This time we're squaring. And this is where the problem comes with a lot of calculators if you don't understand how your calculator works. So if we substitute in the y squared component, like so, some calculators look at that and go, what we're really doing here is squaring that 2 first. So 2 squared is 4, and that becomes negative 4. So that's wrong, because what we're actually doing is substituting in negative 2 squared, all in brackets, which is negative 2 times negative 2, which equals positive 4. Okay, and this is one of the reasons I recommend using brackets. Some calculators do it automatically and some don't, and so the error comes particularly with squares and negatives, that it gets that calculation incorrect. It's important you check your answer for that very reason. So let's substitute in, same as before. X is 3, so we put that in brackets. Y is negative 2, put that in brackets. So 3 squared is 9, and negative 2 squared, negative 2 times negative 2 is positive 4. So we get 9 plus 4 equals 13. Now, don't forget some of these things over here. Things to remember, 2 pronumerals beside each other means to multiply. If there's no coefficient or number beside the pronumeral, it means that it actually means 1 times, or 1 lot of, 1 group of. When substituting, always place your numbers in brackets. This avoids any issues your calculator may have. Now here's another example. This is a physics example, so an example from science. X is displacement. It equals ut plus a half at squared. So this is a formula used for distance. U is the initial or starting speed, a is acceleration, t is time in seconds. So here's a question to go with that. If we look at what we have, important information here, 50 meters per second is our speed, our starting speed. We accelerate for 6 meters per second squared for a time of 7 seconds. What we want to know is how far we travel, which is x. So let's summarize that. U equals 50, A equals 6, T equals 7, and we're trying to find x. We're just going to substitute all those values into this formula. So wherever we see a U, we replace it with 50, and I'll put that in brackets. T becomes 7, we multiply, plus a half times A, substitute A is 6, and then T, 7 squared. Work this out, it's 350 plus 147 is 497 meters. So after 7 seconds, that car has travelled almost half a kilometre. Here's another example working the other way. If the car travels for 500 meters in 10 seconds, let's have a look at that. That's our distance, time is 10, acceleration is 7. What's our initial speed? That's u. So let's look at that. We summarize that information by stating our variables, and we substitute in 500 equals u times 10 plus a half times 7 for a times 10 squared for t. We simplify the parts we can, so u times 10 is 10u. This part here is 350. Now we undo that equation, we solve that equation. We'll focus more on this later. So we subtract the 350, we get 150 equals 10u, and then we divide by 10 to get the u by itself. So our initial velocity is 15 meters per second. So that's what we're trying to do today. That last example was probably, let's just go back to it, that last example is where we're heading. It's probably not something you need to be able to do right now, although many of you may recall it from last year when you solved algebraic equations. So hopefully from this lesson you've been able to identify different algebraic terminology and classify the different elements or components of expressions and equations.